So this is my card. So let me first introduce myself. My name is Fanis Prodromou. I'm a Google developer expert for Angular. I'm a senior Angular developer at the company ASI. I'm a co-organizer of the Angular Athens Meetup, and also I really like this kind of title. I'm an Angular content creator, and I try to be active by creating videos, articles, giving talks like here. And by the way, Kirill, many thanks for the invitation. Thanks for having me. And if you want to connect with me, this is, yeah, I have to change the logo, I guess. X, Prodromou F, Angular Love, this is a great place where I have moved now and I write all my articles here into the Angular Love. And of course, I mirror them into my official one, which is blogprofanis.me, and Prodromou F, my LinkedIn. Please connect with me. And this is my YouTube channel, Code Shots with Fanis. I have more than 7K subscribers. This is a bit of old screenshot. I have more than 60 videos. I guess that you will go there and you will find something that you really like. If you see that something is missing, please just ping me by any message, LinkedIn, Twitter, you name that, and I will do my best to create a video for you. And the today's talk is about the defer block. Learn how to use the Angular's defer block to improve performance. So I have been thinking of how can I explain the defer block? And I think that to explain something, you have first to face the problem. So let's face the problem. Let's assume that we have a page. This is a very simple application where we have three features. The yellow feature, which has this kind of content. We have the cyan feature with this content and the purple one with this content. As you can see, we have three different features. And now let's visualize what kind of routing configuration we have. So for the yellow, we have this kind of configuration. For the cyan, we have this guy. And for the purple, we have this guy. Nice. So let's now see what is happening in terms of compilation. So in terms of compilation, Angular understands that we have three different features, yellow, cyan, and purple. And then we have the compilation part, and it realizes that we want, based on our routing configuration, it realizes that we want to have everything eagerly loaded, which means that these three features will be included into the main.js. And you know what? Everything will work just fine. So do we have an issue here? Since everything works fine, do we have to improve something? So this is a very small scale application. If you can imagine an enterprise level application where we have many different pages and components, you can realize that the main.js will be a very big file. So the issue that we have here is a violation on two different metrics. The first one is the LCP, which is the largest contentful pane, and the other one is time to first byte. So the bigger the file is, the more the user has to wait until everything is being loaded. And of course, this is a violation. So how can we solve that? The solution to this problem is the code splitting. This is not a new term. Perhaps you have faced that before. But with code splitting, what we mean is that we try to create different chunks. To achieve the code splitting, and before even we go to the defer block, we will see how to do that into the routing configuration. So we have the path yellow, and as you can see here, we have a load component function, and we have to provide into the import the path of the component, and then just grab the class name of that component. Nice. So this is for the yellow path, this is for the cyan, and this is for the purple. And now again, let's see what is happening during the compilation. Again, Angular sees that we have three features, yellow, cyan, and purple. And during the compilation, knows that we're no longer going to have everything eagerly loaded, but instead lazy loaded. So for this reason, it will create for us the chunk yellow, chunk cyan, and chunk purple. We will also have the main.js, but let's focus only into these three different chunks. And of course, the main.js won't be that big anymore. So this is a first approach to solve the problem. So let me ask you here the following question. How about, let's think that a bit. If we have this feature, and this feature is very big, and we want somehow, after a performance metrics, we want somehow to split that to half. How can we do that? And when I mean to split that to half, I mean to split the chunk cyan to do different chunks, chunk cyan 1 and chunk cyan 2. So how can we do that? And one might argue here and wondering, why do we even have to split that? Since we have only one feature, why do we have to bother and doing that thing? When we have a UX team, the UX team, what is doing is that they have a page, and into that page, we might have different flows. And we might have a user flow A for a different user, and this will activate chunk cyan 1, and perhaps we have a different flow into that feature, the user flow B, and that will activate the chunk cyan 2. So in cases like that, we don't want, for example, the user B to activate A or A to activate B and vice versa. So we want to have a feature loaded very fast for every user. To achieve that, before even using the defer block, we can do something like that. This is a valid code, and what we have to do is to create a component instance. How are we achieving that? We provide the import, provide here the path of the component, and then grab the class of that component. This is something identical to what we did previously into the routing configuration. And then, since we have here the component instance, what we are doing is that we have the view container ref, we invoke the method create component, and into that method, we are providing the component instance. And everything works well. However, how about if we have a very big component? Wouldn't it be nice in terms of user experience to provide a loading indicator to the user that something is happening, something is loading? It would be nice for the user to know that something is loading for me. And the same goes then with cleanup. We have to pay attention that if, for example, we use the create component more than once, we will create 2 instances. And in any case, we need to clean this up to avoid having any surprises. And how about error handling? So you might be wondering, why do we need to have here an error handling? So let's think the following. Let's think that we have this part of the code, and this is something that will be activated upon user interaction. So a user has to click just a button, and it will run this kind of code. And now let's visualize that. Let's imagine that you are, I don't know, somewhere into the metro, underground, sorry, and during that time, you are out of signal, and you are clicking the button, and nothing happens. Wouldn't it be nice to have an error handling and mention to the user that, you know what, something wrong happened? So for all of these cases, despite that we have the way to go, we need something better. And don't forget that since we try to lazy load that, and since we want to have a different chunk, you do not have to import the cyan component into the imports. Otherwise, Angular will think that we're going to have that into the main.js instead. And this is the problem. And now let's see the defer block which solve all of these issues. So the defer block is this kind of thing. Imagine that we have this component selector, which is appcyan, and the only thing that we have to do is to wrap the appcyan into the defer block. No more than that. So just by doing this, let's see what will happen during the compilation. So here what we have again is 3 different features. We have the yellow, we have the cyan, and we have the purple. This time focus into the cyan. The cyan has a component tree, and it knows that one of our components is wrapped with a defer block. And for this purpose, during the compilation, Angular will create for us the chunk yellow, will create the chunk purple, and then it will create chunk cyan 1 and chunk cyan 2. And we achieve that just by using the defer block, no more than that. And it works just great. But wouldn't it be great to control that even more? And what I mean to control that even more is that when we're using the defer block, we are creating a chunk, and we are displaying that to the user. Wouldn't it be nice to decide, the developer to decide when to do that, when to fetch and display. That's why we have the when keyword, and the when comes with a Boolean expression. This means that when this guy becomes true, is visibly becomes true, at that point of time, we will fetch the lazy chunk and display to the user. And like I said previously, it's very nice also to pay attention to the UX, and you will see what I mean with the UX. So we also have here the placeholder, but before I explain this kind of thing, let's ignore that for a while, and let's think that you are entering an application, and into the application you click the register button, and you see just a form, a registration form where it says name as a label, and then you have an input. And into that input, it has enter your first name. This is the placeholder. And the placeholder, what it does is that it helps the user to know what to do. And this is what we have here in that slide. The placeholder acts somehow in the same way like the placeholder that we have into the input. It informs the user that something will be into this place very soon. And as I say here, this code will be overwritten with the cyan's content. But again, for the UX purposes, we need also to have here the minimum of 500 milliseconds. And why we need that? To avoid to prevent having a flickering. It's not nice to have something like the placeholder just for 10 milliseconds to be like visibly invisible. It could be very, very bad for the user. And for this reason, the Angular team decided to have here the minimum, and we are responsible to provide the amount of time. And then again, into the defer block, other than a placeholder, we also have the loading. So what we are achieving with the defer block? With the defer block, we are achieving to defer loading, right? So since this is what we are doing, wouldn't it be nice also to have a loading indicator to the user that something is happening? So that's why we have here the loading. And similarly to the placeholder, here we also need to have more control to avoid having a flickering. So for example, we can be like, you know what? I want to display this loading indicator after 100 milliseconds. What does that mean? So this means that if this component is very small, or if the user's network connection is very fast and is less than 100 milliseconds, then we're not going to display the loading indicator. Otherwise, we will display that. And we can also be like, if you display that, I want to stay there for 1 second. And how about if something goes wrong? If you remember previously, we said about the underground, and into that case, if something goes wrong, it would be nice to inform the user that, you know what, we failed to download that. So this is what we have in terms of the defer block. And currently we discussed the when keyword, and then we saw the placeholder, the loading, and the error. But now let's focus here into the when. So currently we just saw that we have one control, when with a Boolean expression. Wouldn't it be much better to have more control into that? That's why now we have the on keyword, and the on keyword is very powerful, and we will see all the options that we can provide to the on keyword. And the syntax is defer and into the parentheses on and then idle. So idle is a command and action actually predefined from the Angular team. And the underlying implementation, it's very important to understand the underlying implementation of this one is the request idle callback. And what this is doing is that when the browser is idle, which means when the browser has nothing to do in terms of heavy task, at that point of time, we will fetch and display the content of the cyan component. And then we'll have another action, trigger action, which is immediate. And this means that we will fetch and display immediately during the template execution. So at that point of time, we will see the content of the cyan content. And then we'll have the interaction. I really like this one. So interaction, and we have here two different cases. We have the implicit and we also have the explicit. We will start with the implicit and we will see what the explicit is and why we need that. So the implicit means that whenever the user interacts with this block, and what I mean with this block is that if we grab this code and we paste that into our HTML template, then into the browser, what the user will see immediately will be just the placeholder, just this guy, no more than that. So if we have the on interaction, it means that when the user interacts with this block, meaning to click that, at that point of time, we will fetch and display this component. So this is the implicit. And then we have the explicit. And as you can see here, I do not have the placeholder. We don't need that. And the reason is that now we are providing a trigger point. And we are saying that whenever the user clicks this button, where we have the template reference variable, at that point of time, we will fetch and display the cyan component. And please note that into that button, we do not have a click event. Everything is handled automatically for us by the interaction action. In the same way, meaning with the interaction where we have the implicit and explicit, we also have here the hover. And again, whenever the user hovers over the placeholder, at that point of time, we will fetch and display the cyan component. And of course, we have now the explicit, which means that on hover, and we are providing here into the parentheses and template the reference variable, which means that whenever the user hovers over that button, at that point of time, this component will be fetched and displayed. And then we have the viewport. I really like this one. So viewport means that whenever the placeholder enters the viewport, at that point of time, we will fetch and display. And of course, then we have the explicit one, which means that whenever that button enters the viewport, we will fetch and display. And that the line implementation of the viewport is the intersection observer. And you might be wondering here, why do we need to know about the underlying implementation? It makes more sense, or at least it helped me, at least during the unit test, to know how to unit test. And then we have the last one, which is on timer, which again, the underlying implementation is set timeout, something like that. And we're saying that I want to fetch and display this component after 1 second. So either we type here 1000 milliseconds or 1 second, it's the same thing. But again, here we have one question. What if the component is super heavy? How can we solve that? How can we achieve that? So in this case, we can prefetch. If we have a very big component and we're going to achieve a very good user experience, perhaps we can prefetch that. The action, the command to type the prefetch is defer on action, semicolon, prefetch, and then we have to provide how to prefetch that. And we have different examples. Here, what we can see is a combination of on action with prefetch on action. And an example could be, I want to defer that on timer 1 second, and I want to prefetch that on immediate. Another example would be to use a combination of on and when. Defer on action prefetch when a Boolean expression. For example, I want to defer that on timer, and I want to prefetch when it's true. A Boolean expression, just a variable. And of course, you can see the other combination is when and on. For example, when is true, prefetch on timer. And the last one is when and when. For example, defer when is true, prefetch when something else is true. So these are all of different combination of how we can use the prefetch. And now let's see some live coding. So this is a very small application, and as you can see here, I have my path with main and a component and main component. And this is what we have in terms of output during the compilation, my build. But before even we go into the code, let's see what we have. Let me just reload here. And what we have is just an Angular survey, a very small Angular survey, where it has your favorite Angular version. We can go 2, 4, 5, up to 17. If I select, for example, any version, 14, 5, or whatever, does nothing. But if I select Angular 17, now we can see these kind of things, the sliders. And it says, how much do you like Angular 17 features? These are just a subset of these, of Angular 17. I very much like the logo, the documentation, the control flow, the if block, the for block, switch block, defer block, and I really like the automatic migration to new built-in control flow. And then we have a choose the date, which is just for real estate, does nothing. So this is how the application looks like, which is a very small application. And we will try to improve that. So let's go back now to VS Code. And what we want to see is that during the build, let's focus into the main JS, which is the main chunk. And here we can see that we have 2.89 mega. Nice. So I will comment this out, and I will convert that into a lazy. Just to have here a code splitting, like we said previously. Immediately, what we can see is that the main JS is no more that big. It's less than 200K. And we have here a chunk, the main component chunk, which is 1.4. Nice. So if we go to the application, we expect everything to work as expected. Everything works just fine. So can we improve that even more? If we go into the main component, we can see that here we have the Angular survey. This guy is this guy here on top. Okay, so how about what would happen if we wrap that into the defer block? So I would have here my defer block, just this, and as you can see now we have more chunks. So here we have the main component, and we have one more chunk, which is 1.4. Nice. And this is what we are achieving by using the defer block. And if we go to the browser, let me also open here this guy, no throttling, and I will just reload. And if I go to JS, here we have all of the chunks, and we expect everything to work as expected. Nice. So let's now give it a try to have a placeholder, an error, and stuff like that. So for example, I can be like, I want here to have a placeholder. And for the placeholder, I want to have something like, this is the Angular survey component, something like that. So let's try to see what is happening. If I reload, nothing is happening. But if I reload again, pay attention that we have a flickering, right? Which is not nice in terms of user experience. So how about now, if I have here a minimum of 1 second, I'm going to be there for 1 second. Now, if I reload, it makes more sense for the user. For example, 3 seconds. This is the Angular survey component. At least in terms of user experience, now the user can read, has the time to read what is happening there. And how about the loading indicator? I can be like, I want to display just a div, and the div will be like just loading. Let's see. I will reload, and here we can see again that this is the Angular survey component, and boom, it goes immediately with the content of the actual component, but we do not see the loading indicator. So let's give that a try. What I'm going to do is that I want to have here on interaction. And if you remember the interaction without providing a trigger point, what it means that as soon as the user clicks the placeholder, at that point of time, we will load the component. So let's see. Now, the placeholder will remain there forever until the user clicks this guy. So if I clear my network and click here, as you can see, we have just downloaded that chunk. Let's go again and do that once more. And the goal here is to see the loading indicator, right? So I will click, and we can see the loading indicator just for half a second. So let's see. If I go here and be like, I want to see that after 100 milliseconds, and I want to stay there for a minimum for 30 seconds, something like that, what would happen? This is the Angular survey component, clear everything. Now we do not see the loading indicator. The reason is that we have a combination of either a very small component or a very fast network connection. So let me do that again, but this time I will use a throttling. And I will go with perhaps this guy. I will click, this is the Angular survey component. It goes fast. Let's do that once more. And let's try with slow 3G. Yeah. And now we can see that we have the loading indicator, which makes more sense for the user that something is loading. And how about now the error? So for example, for the error, we can have something like, yeah, Copilot. Let's see what we have here. There was an error loading the Angular survey component. Yeah, it works. So let's see. Let me remove the throttling. And like I said previously, the error works whenever we have a network exception. And for this reason, I will go completely offline and I will click this button, and now we can see there was an error loading the Angular survey component. So in terms of user experience, I think that we have already achieved very good state to inform the user for what is happening there. So let's go back without any throttling. And so far we have improved the application. And my question is, can we improve that even more? So if I go into the Angular survey, what we can see here is that we have the autocomplete, ignore the code, doesn't matter for this talk. We have the autocomplete, and then we have here just the date, which does nothing, like I said previously. And then we have here just an if condition. And the if condition, it says that if the form value Angular version equals 17, then I'm going to display the Angular 17 features, which is this guy with the sliders. Come on. Which is this guy. And here's my question. If you remember during the initial presentation with the slides, I said that perhaps we have different users, user A and user B. Perhaps a user A could be with Angular 6 and another user could be with Angular 17. Why do we have to load this kind of component for the user which has an Angular less than Angular 17? Doesn't make sense, right? So for this one, we can improve that. And instead of having an if block, we can switch that to a defer block. And here we can have a when keyword. And now we have just created one more chunk just by using the defer block. And this will be enabled only when the user selects Angular 17. So let's see that in action. We are loading that. And now let's see. If the user now goes and select Angular 17, where is all? Let's give that one more. Angular 17, somewhere here I would expect to have my chunk, but I do not see my chunk. I will give that one more try, and if not, I will skip that. I would expect that to be a different chunk, and change that with files, application bundle, page reload, send to client. You know what? Let me kill that and rerun that. Okay, so let's see once more. Clear everything. This is the Angular survey component. And now I will select Angular 17, and yeah, here's our chunk. So we have just downloaded that. And this is how we can improve the performance of this page even more for the user. And of course, here we can have different variations in terms of I'm going to have a placeholder, I'm going to have an error, and I'm going to have a loading. I'm not going to add them here, but what we can do is play around with the prefetch. So let's say that I'm going to prefetch that on idle. So we will do the following. We have here when an Angular version equals 17, and we saw previously that when we selected the Angular 17, at that point of time, we downloaded the chunk. So let's try to do that once more. But this time, what I'm going to do, clear, and I'm going to have something like slow 3G. And let's select Angular 17. And as you can see, we do not see here the chunk. The only thing that we saw was the request to download the image. But where is the chunk? What had happened is that we already downloaded the chunk. We prefetched the chunk for the user. And despite that the user had a very slow 3G connection or whatever, that one was very fast for the user. And of course, we can use here any different combination when prefetch on idle or you name that. And this is what I wanted to show you of how to use the defer block and all of the different variations. So let's go back now to the slides, which is the last slide. And we still have one violation here. And the violation here is the CLS, cumulative layout shift. What is happening is that whenever we're displaying content, is shifting the rest of the content below. So that's why the recommendation is to use the defer block below the fold to avoid having a cumulative layout shift. However, we can have a trick here. Since we have the placeholder, and since we know the dimensions and the content of the component, perhaps we can have a placeholder, and that placeholder can have the same dimensions of that component, meaning width and height. So if we have a placeholder with this kind of dimensions, then we won't have a layout shift. And this means that we can even use the defer block above the fold. And that was from my side. And if you have any questions, I would be more than happy to answer them. Thank you very much.
Okay, Boyan, go ahead.
Anyone, any questions?
Yes, Igor?
I can see Daniel.
Can we use this defer like more for 5, 6, 7, 8, 9 seconds?
If we can use a defer block?
For more than 1 second.
Yeah. You mean the metadata of minimum and after and stuff like that?
Yes.
Yeah. You can increase the time however you like.
Okay. Thank you.
You're welcome.
Daniel, go ahead.
Okay, my question is this defer block. For example, do you see this as a replacement for lazy loading, or should it work side by side with lazy loading to get more detailed control over how the content is loaded, or do you see in the future the defer to be a complete replacement for lazy loading, maybe?
Very good question. Thanks for that. No, I'm not seeing that to be like a replacement of lazy loading. And actually, the defer block is an enhancement of lazy loading. Now we have one more tool and of how to lazy load something. So the existing lazy loading that we have, all the implementation, either being dynamic components, either being routing configuration, won't be replaced by the defer block. So we just have one more thing of how to defer and lazy load our code. Very good question. Thanks, Daniel.
Good evening, Fanis. Are there any constraints for using this feature, or are there some negative aspects of using the feature?
Currently, this is the defer block is in developer preview, which means that it's subject, it's stable, but the API is subject to change. Despite that, I have used that, I can say heavily, and I haven't seen any constraint other than the below default thing, where again, we can use, the placeholder, and if you have the placeholder, you're going to have any layout shift. Another thing that sometimes people tend to do is to replace all of the components with a defer block. This is not the case. So we have to wisely think of how to use the defer block. Do not lazy load all of your components. But other than that, I do not see any constraints.
I have a question. So before the defer block, I remember that when I was doing an HTTP request, I would try to combine and build a custom pipe where I would do loading, template, or result, and I would reuse that in order to get more custom behavior over all of the templates that I have. So I would either get the result, which will be a table, loading while the HTTP request is going on, or some error which is going to indicate my issue. So now with the defer block, do I have to do all of that, or the error itself catches everything that goes bad with the HTTP request and it gets displayed there?
Good question, Kirill. So let me try to gather my thoughts. So there are cases. Perhaps this is what we described. So you know what? Let me try to formulate in a different way. So let's assume that we have somewhere our state management. The state manager is responsible to grab via HTTP something, and this something is very heavy, or we have a slow network connection. In that case, we need just to have, like you said, we have loading true to false so that we can display something to the user. So in this case, perhaps the defer block won't replace that. So the defer block, the idea of the defer block is to replace the heavy components. So this one that you described with the loading indicator. I see that more like on the HTTP level and not because we have a very heavy component. So perhaps we can have both of them.
Okay, I understand. Thank you.
Good question, Kirill. Thanks so much.
Yes, Daniel, go ahead.
Yes, I have another question. Is the defer block something that could previously be replicated without a defer block and do the same thing, or is the defer block completely unique and it cannot be replicated using different methods and logics in Angular in previous versions?
In previous versions, you could use dynamic components. The code that I showed, perhaps I can share my screen a bit. Give me a sec. I have to find that guy. Yeah, this one. So with that piece of code, you can create a chunk and you can fetch that chunk, which is perfectly worked. And this won't be replaced. This is still valid. And there are some cases that we will use that, and we will have some other cases that we can use a defer block. If this is, Daniel, your question.
Yes, but also is there anything in the defer block that's like completely unique that cannot be replicated? Like you said, it can be used side by side. Like this won't be replaced, but Is the defer block some features of the defer block that can never be replicated, like maybe the placeholder or something?
This is, I'm sorry for that, but this is what I'm missing here, that you're saying that won't be replicated. What do you mean by that?
For example, let's say the error block. Is that something that cannot be used previously on previous versions of Angular, like the complete functionality of defer? I'm speaking like as a whole.
I see. For example, we didn't have the placeholder previously, even when we were dynamically loading the components in the code that I showed previously. We didn't have the placeholder, we didn't have the loading indicator, we didn't have the error. So all of that, we had to do that manually. And the defer block is not like a different way to lazy load, but it also gives us more functionality in terms of, if you remember, the when keyword and the on with the trigger actions. So we have this kind of combination that makes it powerful.
Perfect. That was my question. Thank you.
Okay. Glad that I managed to answer that.
Yes, Alexander, go next.
Yeah, so my question would be like, since I'm trying to wrap it up in my head, is somehow the for block related to the hydration phase of JavaScript parsing? Like I saw an example of you like stating a trigger, and actually when we clicked on that trigger, we're actually, does that mean that in background we're actually attaching an event handler? So that means at that point of time the application starts to be interactive, that we had interaction. So the question is defer actually related somehow to hydration?
No, I don't. I wouldn't say that it relates to hydration. No, I wouldn't say that it relates to hydration. Hydration more, it's like on the server side thing, rather than into the single page.
Yeah, because I also thought of that with server-side rendering, how it would look like when we also had a defer block and all that to actually integrate into one piece.
For the server-side rendering, though, that's the interesting part, is that the server ignores everything in terms of actions, on action, and when keywords and stuff like that. And the only thing that pre-renders for us and sends is the placeholder. So the rest of the code is being executed into the browser.
Yeah. All right. Thank you.
Welcome.
Okay, if there are no more questions, we would do a 2-minute break, and we'll continue with Angel. Fanis, thank you very much for
Okay.
this wonderful presentation.
Thank you very much, Kirill. Many
It was
thanks.
very nice having you.
Yeah, thanks for having me.
Hello, Angel.
Hello,
So I
everyone.
would like to introduce our next speaker, which is going to be Angel Petrushevski, and he will be speaking about Angular change detection, how it works, and it's going to do a deep dive into it. So make sure to stay tuned.
Yeah. So hello, everyone. A little bit of introduction for myself. My name is Angel, and today I'll talk about mastering Angular performance. We'll dive deep into change detection. Okay. So for today's agenda, we would explain what is change detection. Then we would see the process of change detection, a little bit of history of AngularJS, then explaining zones in Zone.js. We'll dive a little bit here deep into Zone.js and how it helps Angular trigger change detection. We'll see some examples in Angular, and then we'll talk about default change detection, on-push change detection, and immutability. Okay, so without further ado, let's start. So change detection is really a concept that every one of us has come at some point while learning Angular. And sometimes it really can be seen as something complex and really abstract. I remember when I was learning Angular, I had quite a hard learning curve towards change detection because it was kind of a hard process. Meaning my applications were slow. I didn't know why my applications were running slow and how I can optimize them. So we should know here that there are a lot of things that happen behind the scenes in the application. So there are native browser events that are being monkey patched. We'll see what is this a little bit later. And sometimes it seems like there's a lot of magic happening. So today I'll explain to you in simple terms. This is going to be kind of advanced lecture. So if you have any question at some point, just raise your hand and. Okay. I have a question. Ivana.
Sorry.
Okay, it was a mistake. Okay. So at any point, if you have any questions.
Sorry, mistake.
Yeah. Okay. No problem. Okay. So let's continue. What the heck is change detection? So change detection is the process of a framework detecting changes, meaning Angular framework, and deciding what to do with those changes. So a change, it can be either a user action or a real action. So imagine that I have a page and I have some button, and on click, I expect something to happen, maybe something to refresh, or I'll get the latest data. So it can be either an event, a button event, a click event, maybe I will fill a form, or maybe some background HTTP call will succeed. So let's see some real life analogy here. So imagine you're the owner of a coffee shop, and every day you have some special offers. You make those special offers based on the ingredients that you have in the shop. So every time, every day, every morning, you enter the shop, you see what your ingredients are, and then based on that ingredients, you update your menu outside so people would know what offers do you have available at that day. So this is the coffee shop is the change detection, or maybe the logical view. So we need data to update our front, the clients, so they would know that some data has been changed. So while the user is interacting with the application, the framework needs to know only two things. The first thing is when to update the DOM in the browser, and which parts of the DOM do we render, meaning that do we render the whole DOM tree or we render specific parts of our application. So in the process of change detection, here I have some component in Angular, and we see that we have a template that says hello name, meaning that in the process of change detection, when initial change detection happens for this, everything that we have in the logical view of our application gets binded to the template, meaning that we would get hello name. So component data model gets applied to component view. That's one cycle of change detection. So here it's really good to mention that the way that we perceive the components a little bit different of what Angular builds them in the runtime, or how Angular sees them. So here we have two comparisons. The first one is the way that we see components, and the second image is the way that Angular builds the component. So we can see the code. We have some component.component, which calls some function that defines the component. Now here we have some variables like type, selectors, declarations, and variables. But the most important thing here is the template, which is a function. Our logical component, meaning that when we execute the view, every view in Angular component is actually a function in the background. This function has two arguments. The first argument is the render flag argument and the context. So this function gets executed in two parts. The first part is the creation mode, meaning that in this creation mode, Angular just needs to know where the element is located in the DOM, meaning that render flag is status 1 and just marks where is the element start at position 0. We have h1, then we have at position 1 some text, and then element end. And after this creation mode, there is another mode that gets run, and that is the update mode. So here we have the render flags with status 2, and before rendering, binding the logical view, the variable name with the template, we call a function advanced. Now, this function advanced actually advances to the location of where it needs to re-render or re-render the context from the logical view, meaning that this advanced function can take some arguments like integer 1, 2, 3, 4, and based on that, it will go at that location and re-render. And after this advanced function, we have text interpolate, which actually concatenates the hello with context.name. Now, like I mentioned before, in the context, we have everything that is declared in the logical view of our component. So there are only two types of views in Angular. There are logical views and there are template views. Today, we'll only talk about the logical views. And because these are the views that are connected to the instances to our components, each component has an instance of this logical view. Each component is represented with an instance of LView. Okay, I can show you some Angular source code now. We'll just, here I have the Angular project that is cloned from the GitHub repository. And today also I will explain to you some of the code that happens behind the scenes. So this is the LView. Let's see the LView. Yeah, so this is the LView, which actually it's kind of an array in the background, and it has some specific elements like host, meaning that the host element to the view that is attached, read only the template view, meaning the HTML view, some view flags. We'll talk about this a little bit later, the parent and other not important properties for today, and also the context, which we get when we re-render the HTML view from when we call the function from the component. Okay, so about the LViews, there are two types of LViews, the component view and embedded views. The component views and embedded views are represented by the LView. Now, they both are represented by one class called the viewRef class. And in this viewRef class, we also have the host view, which is the view from where this component was declared, called. Let's see the viewRef. This is the viewRef. And the viewRef, as we can see, implements the change detector ref interface. Now this change detector ref interface extends the change detector ref class. Let's open the change detector ref class, and this abstract change detector ref class has some methods inside, like mark for check, detach, and detect changes, and meaning that in the background, this viewRef has to implement the logic of how the component would change when we have change detection happening in the background. So, okay, so let's talk a bit of history here. So AngularJS, if someone is familiar with it, so in AngularJS, which is the predecessor of Angular, so change detection had to be manually run by the framework. So running change detection was done by calling the jest cycles, if anyone remembers that. So there was no way of knowing when the jest needed to be run. So Angular JS did that on specific events like ng-click, or calling the root scope, which was a root parent, meaning that the whole tree would be traversed and refreshed. And also, any HTTP GET would call a scope digest in the background, which would refresh the view, or maybe router navigate, which would manually call digest on the root scope, and same. So this resulted in the entire tree getting traversed and updated, and was bad for performance. And this became a very painful and very expensive task. Why? Because we don't want to refresh something that did not change. So that's what the motivation for Angular came. And so we want our framework to know when to trigger change detection, rather than having our libraries trigger change detection manually, rather than calling change detection in the source code of our application. So Angular used ngZone, that's a library that comes from zone.js. So Zone.js monkey patches native browser events and tells Angular when some event happened in the background. For example, click or mouse over, and stuff like that. So Angular listens on those events, and based on that events refreshes the whole tree structure of the components, meaning that calls that function that we mentioned before, which binds the context with the HTML view. Okay, so what is monkey patching? Here I'll show a little bit example. Okay, so I'll open here the console. I think you can see it. So monkey patching is actually keeping a reference to original function. So I can just keep reference to the original console log function. So I'll place that in some original console log variable. And then I would replace the original console log with a new function. And here I can do some of my changes. So I can just say console.warn, and here Angular would do change detection. And then we would call the original console log, which we had referenced before, with the value that we have to our function, and we'll close. So meaning that every time we would call our function, let's say hello, the change detection would be run. So this is kind of, I think you get the idea of what Zone.js does in the background, how it intercepts native browser events. Okay, so let's continue. So let's talk about zones. And what are zones? So zones is a new mechanism that helps developers work with some connected async operations or events. So meaning that zones work by associating each async operation with a zone. What does this mean? So we can associate a specific function of our code within a zone, meaning that if we have two functions, we can run those two functions in the same zone and intercept both the event that happened in the first function and in the second function. So let's see an example. But first, let's see the relevant zone API. So this is the class of zone. It comes from Zone.js. So we would have constructor. It has the parent zone, some zone spec. Then we have a static method current, which returns the current zone that is active. We have some get name, get parent, and the important thing here is the zone run, which we would call to synchronously invoke a function in a given zone. So meaning that when this zone.run is set, it sets the current zone to Z based on what zone we call, and then sets the parent zone to the previous, to the parent zone that is previously, if there was a parent zone. Okay, so let's see this example. Here I have three functions, function A, function B, and function C. So in regular JavaScript environment, the stack frame for any for the function is not way associated with the stack frame for function A. So meaning that two functions are run in a separate stack frame. So what Zone.js allows us to do is to associate each stack frame with a particular zone. So let's see the following example. So we have A. So first we have the global stack frame. Then we have A, which gets pushed to the queue. Then we have A calls B, B is pushed to the queue, and B calls C, and C is pushed to the queue. Meaning that when C is done executing, C is popped from the queue, we have the B, A, and then global. So I think you get the idea here. We want to run A and C in a specific zone, meaning that maybe we would want to share some context between A and C. So we want to create a zone here, zone A and C, which A would and C would run in the same zone, and B could run in some other isolated zone, let's say zone B. So how we can do this using zone.js? So let's create first the zone AC. So we call zone current fork with name AC, which would create a AC zone. And then we would call zone B, zone current fork with name B, which would create a zone B. Now, how do we invoke these zones in the function? So with previously declared variables, we can just say zone AC run function A, meaning that when we console log zone.current.name in function A, we would get the zone AC. Now from function A, we can switch to another zone, zone B, and we can run that function B in zone B. And from function B, we can switch to zone AC by running ac.run function C. So, and maybe so this is just a reference to get the idea of how zones work. And maybe we want, I don't know, some shared context or some shared state that functions A and function C would like to share, and we can access that state using also zones. So also, probably most of new.js developers have become familiar with this. And using setTime method, I think every one of you has heard about setTime method. So what this setTimeout method does is allows postponing an execution of a function. So zone calls the setTimeout async operation a task. So zone has two kind of tasks. So we have a macro task and the micro tasks. So macro tasks are tasks that are like set timeout, set interval, which are executed after some point. So let's see this example. We have function B, which calls set timeout of a function C. So the question here is, in which zone would C run? Meaning if zone current name is in BC. So because function B is already in some zone, the set timeout function would also be in zone BC, but after 2 seconds wait. And after this, it would just get back to the parent zone, which is zone A. Okay, so the question now is, okay, now we have some event, some set timeout function that happened in my BC zone. So how we can intercept the set timeout knowing that some event happened in our function? So remember when we called, when we create a zone, we also have the zone spec, which has a method called onHasTask. So what is onHasTask? This function onHasTasks gets called every time we run some function. So every time this queue change of events happens in the DOM. This. So it has some properties like change, macro task, and hasTask change, and we can intercept, and we can just do if hasTask change state.change. We can do some logic. Maybe we can do change detection or run something in our code. Okay, so enough with zones. I know it was kind of complicated, even for me, but let's get back to Angular, because now we'll talk about the zones in Angular. So Angular, what actually does, it uses only 2 zones to trigger a change detection. The first zone is the parent zone, which is outside Angular, meaning that it would not trigger change detection when any event happens. So it would not refresh the view. And then the inside Angular zone, which will trigger change detection when event happens, like set timeout or set interval. So, Okay, so the default change detection strategy. So we get the default. So when you first start your Angular application, you can see that any change that you do to your HTML view, to your logical view, gets refreshed and propagates to the HTML view. So by default, Angular runs in the inner zone. So in the bootstrap process, when Angular initially creates itself, it will run change detection after the initial creation of the component, and it would call a function called refresh view that comes from the viewref, and viewref in the background would call detect changes that will execute those functions that I previously explained to you in the initial slides, which would just concat, apply the context from the logical view to the template view. So detect changes calls refresh view, and then this part of code gets executed. So we call execute template with the template function, and here is the render flags.update, which we saw previously when we were seeing how the SOM component has a function that updates the hello name, meaning hello Angular. And also, when this happens, so when change detection happens for a specific component, it actually gets all the child views from that component and also runs change detection in the child component. So it would recursively call itself until all of the children have been finished and have been refreshed. So let's see this in an example. Enough with talking, let's go. Okay. So here I have hello Angular, which is an application. Now we can set on init this.name something other, and because the name changes, it would actually run change detection. Or maybe we can say set timeout, and we would update our name in after 2 seconds. So now Angular uses Zone.js to intercept the event and actually calls, meaning that this event would happen in the entire tree structure. Now, how we can disable change detection? Maybe we don't want initially when the application is bootstrapped to run change detection. We can go to the main TS file, and we can provide here a configuration called ng-zone. And with the value is noob, meaning that now initially when the application is bootstrapped, it will run change detection because it always runs the first time. But now after 2 seconds, we can say that this name did not change, even though this was executed after 2 seconds. Why? Because we are not listening anymore for any events that happen from our logical view. Okay, let's remove this. For this tutorial, we would use ng-zone. Another way we can trigger change detection is we can switch between zones. So we can switch anytime from our parent zone to our children zone by injecting the ng-zone. So let's run this set timeout. In ng-zone has, like I said, 2 methods. The first method is run outside Angular. So we would run meaning that if we run this set timeout function outside Angular, it would not trigger change detection. But now let's say that we did something and then we would like to update the DOM. So in the set timeout function, we can just call again ng-zone run, which will get back to the child zone. And we can just update this name. Yeah, there it is. So we can use this to leverage and to escape specific events that we don't want to trigger change detection in our application. Okay, that was the first example. Now let's see the second example. So here I have a tree structure of an Angular application. This is the Angular application. Imagine that you have this kind of Angular application. So we have level 1, level 2, and level 3. So let's say that I'm at level 3.5, or I'm any of at these levels, and some event happens at level 3.5. So let's go to level 3.5, and let's add the set interval event. We won't have any logic. We just say on every 2 seconds, please refresh the third level component, meaning this. But what we expect to do is this happens to our entire application. So this is not a good, this is bad for performance because we're refreshing views that are not needed to be refreshed. So another example, let's say that we have some buttons. Let's introduce some buttons to our application. So mark, let's call this button mark. Okay, and now let's add a click handler on this button. Even though I don't have any code, Angular doesn't know that I don't have any code, so it just intercepts this event, and meaning that every time I call any of these buttons on specific component, it refreshes the whole tree structure. Why? Because change detection always starts from the up root and refreshes all the views. Even though, yeah, we can add also if we have some buttons at level 2, it does not matter when where this event, click event has happened, it would still refresh the whole application. So this is a problem because imagine that you have some expensive UI components that are hard to render, and meaning that we don't want to refresh every time a user interacted with some other component because it's bad for performance, it would get laggy, a very bad user experience. So this is where the second part comes in. So Angular introduced another property called on-push change detection. So like I said, it's very clear that the default change detection strategy will trigger change detection on all the views, regardless of where that click event happened. And that could be bad for performance. So Angular introduced the logical view with status. So each logical view can have some specific statuses. Let's see the L view again. Okay, let me get back to the L view. There it is. Okay, so we have the render flags, the LView flags. So this LView flags has specific modes like creation mode, first view pass, and today we're interested in this flag that is dirty. So if an LView flag is with status dirty, it means it would refresh that specific view, but also all of its parent views. So what does this mean? So let's try to optimize our application a little bit and see how this on-push change detection strategy runs. So let's introduce in each of our components change detection on push. So this is the property that we set to each of the components. So let's go to third component, second level component, and first level component. Now let's see what would happen to our application if we click a button. Do you see the difference now? It only refreshes level 3.5, its parent, level 2.3, and level 1, and does not refresh the level 1.1 views. So this is better now because we have optimized our application. So, but this only works if, so imagine that if we did not have a level 2.3 as on-push strategy, it would still not work. It must, every parent, it must have change detection on push. Okay, let's see another example here. And the last thing that, yeah, so even though we had on push, component refresh would still happen in this. So meaning that change detection can happen on a component if regardless of anything, if we have these 4 conditions fulfilled. So one of the inputs of a component changes, it is set by a parent component. Imagine that the child component has an input property and the parent component passes this input property to the child component. This will trigger automatically change detection, regardless of not if we have on push or default change detection. Binding to an output. So if our child event emits some output to our parent component, it would still happen. It would still be run a change detection. Or maybe an async pipe is done in our HTML view, or we can manually inject the change detector ref and call mark for check functions. This mark for check function will trigger a mark view dirty with status dirty, and then it would just run the change detection of its child and its parents. So also, when dealing with on-push strategy, a very good example is to remember to always work with immutable data. What does this mean? So imagine that we have 2 objects, 2 functions. So we have before, we have function object with property foo and a value of bar, and we change the reference. We create another object which has the same structure of before, but if we change current.foo with another name, this would still be the same object, regardless of having different values. The first one having bar and the second one having hello. So when we work with immutable data, meaning that we can change the object, so we must reassign it to another object with a new value, then this would result in false, and meaning that, okay, maybe something changed, maybe I can manually run change detection by injecting the change detector ref and calling detect changes for the view. Let's see an example. Here I have another data structure which has an update method. Let me create that update method first, and then I'll explain what it does. Okay, it takes an ID. Let's see the view. Okay. So here we have some data. So for each of this view or component, we have introduced some data. This is the data structure that we're working with. We have level 1, which has an ID of level 1.1, and its children, level 2.1, level 2.2, level 3, and I think you get the point. So let's say that we want to modify this piece of code, level 3.4, let's say, the last, or yeah, level 3.5. Okay, let's go. So let's say that we want to change the ID of this element, or maybe the label. So we would call a function update node 3. This update node 3 would just mutate the object. So what it does, it actually finds the node and updates and change its label and adds a little exclamation mark next to its label. So when we call level 3.5, it would update the level 3.5. Or maybe we can call level, let's say level 3.4, and it updates level 3.4. But what's the problem here? It's good, but we can optimize this furthermore. Why? By calling a level 3.4, we also refresh level 3.1 and level 3.2. Why? Because Angular does not know if those levels changed or not. So it cannot compare itself. So how we can allow only the change to happen on level 3.4, level 2.2, and level 1.1. What we can do here is add a track by function, because it uses ng4, and we can track, and that track by function would just compare the element, like I said from this example, with if it's the same reference or not. Since we mutated that reference, it would only refresh the mutated references. So let's introduce the track by function here. So we can call track by, and let's create a track by function. It would take an argument of I, and it will return I. And let's add this track by function to every level of the components. Third level, we don't need it in third level. We need it in second level. And also in first level. Okay, so let's see what happens if we update level 3.4. I think we still get the same behavior. Wait, something is missing. So app component has a track by function. Okay, the first level does not have a track by function. Or the third level, it has a track by function. Second level, track by function, and the first level also has a track by function. Let's refresh the application. Let's see now. I'm not getting the desired behavior. Yeah, any question? No, it would still get the object. I don't think it's needed, but we can try if you want. Let's see. Okay, let's see now. Maybe that would help, but no, it still updates the whole DOM tree. Maybe I'm missing something, but let's see the function that updates is the DOM tree. But now if we call L35, it only refreshes the 3.5. It does not refresh these other views, which is good. But when we update 3.3, it also updates 3.4, which is not a desired behavior. Let's see if I can try to find and fix it. If anyone has any idea, you can just raise your hands. We'll try to work.
Nico says there is another ng4 inside.
Another ng4. Oh yeah, I forgot about this ng4. Yeah, thank you, Nico. So now I think it would work. I forgot completely about, yeah. So it must, so we must add the track by function to any of these ng4s. So now let's update it, but it still does not work. Let me check again. Ah, there's another one. So let's try it now. We still don't get the desired behavior. Track by here. Second level component has track by also, and the first level component has also track by function. Maybe because of this. And this fourth, we forgot about this. And now if we update, there is this the desired behavior. So even though we updated only level 3.4, we only update its parents and we completely ignore the other components. So we get the desired behavior. Thank you for your help. If there is any other question. So let's get to the final slide. So when not to use on-push change detection strategy. So components that will often call HTTP calls or maybe other async tasks is not recommended. Also for components that are getting past mutable objects like form control or form group is also not good practice. But maybe if you're a change detector expert, if you use it so often, you can use it mostly on all components. So it would not be any problem to you. So thank you for your attention and thank you for taking your time. I hope I understand it in simpler terms, what is change detection in Angular. So if you have any questions, I'm here to answer them.
I think Costa Krabowski was first, so Costa, go ahead.
I just wanted to send the claps.
Any questions? It was a complex topic. I tried explaining it very simple.
If there are no questions, I posted the feedback form in the channel. So guys and girls, please feel free to give us a feedback on what we need to do better. And that would be all for the session today. If anyone wants to stay and speak or do a little bit of networking, feel free to do so. Thank you everyone for joining.
Thank you.
Thank you. Goodbye.